Okay, dear students, today we'll start new chapter, that is chemical reactions and equations. See, dear student, first of all, we need to know that what is a chemical reaction. Chemical reaction is a process in which any new substance is formed, and the new substance formed is having fully new properties. What is a chemical reaction? It is a process in which a new substance is formed. New substance is formed with with new properties. With new properties. Let us take a single example. Whenever magnesium ribbon is burnt, that time magnesium reacts with oxygen. Okay, if we burn the magnesium ribbon, then magnesium reacts with oxygen and we get a product that is magnesium oxide. Very important. See, my dear students, it is a process in which new substance is formed with new properties. Very important. First of all, you need to know the substance which take part in the chemical reaction. Means these are the substance which are taking part in the chemical reaction. These are known as reactants. These are known as reactants. Reactants go through chemical reaction. This arrow indicates that now reaction has taken place, and after reaction the substance which I get is called as product. Is called as product. So what is a chemical reaction? Chemical reaction is a process in which reactants combine, go through reaction, and after reaction I get products. The properties of products is fully different from the properties of reactants. This property, matlab this magnesium oxide is fully having new properties. Oxygen is a gas, magnesium is in solid ribbon form, and this magnesium oxide is a powder, a white powder which you get after this reaction. Very important, dear students. Why do a chemical reaction take place? And if any chemical reaction is taking place, what happens and what thing has taken place in that all the elements and all? Now we will see. Just for example, just for example, AB is a reactant and CD is another reactant. Chemical reaction taken place, we got a product AC plus BD. Very important. Why chemical reaction has taken place? See, A and B, these are two different elements and it is a compound. Just let's take for example, this compound is having a break, is having a bond, is having a bond. Okay, this C and D, these both also have a bond. After chemical reaction is taken place, element A and C is combined and now they are having a bond between them, and element B and D has combined and they have a bond between them. Very important. What has happened that there were bonds before reaction, there are also bonds after reaction. A has broken previous bond, bonds are broken and new bonds are formed. Very important. In a chemical reaction, old bonds are broken down and new bonds are formed. New bonds are formed. Very important. Here A and B were having a bond in this chemical reaction. This bond has broken down and now A has made a bond with C. Means a new bond has been created. So in a chemical reaction, previous bonds break down and new bonds are being formed. Second very important thing, there is rearrangement. There is rearrangement of atoms. See my dear friends, as you can see, okay, these all elements and their atoms has rearranged themselves or had arranged themselves in different setup. They have changed their setup, they have changed their positions, because of which new material we have got with different atomic positions and different bonds. So what is a chemical reaction? Chemical reaction is a process in which we get a new substance. That substances taking part in a reaction are known as reactants, and after reaction the substances which you are getting are products. Okay my dear students, it is a very common thing. If any chemical reaction takes place, we get some hints or indications that yes, chemical reaction has taken place. If we don't get these indications, it means no chemical reaction has taken place. Just for example, I will give you common examples of chemical reactions. Okay, rusting of iron. After that is milk converting into curd. Burning of paper या फिर burning of any fuel. See my dear friends, all these things give some indication because of which I can get to know that yes, chemical reaction has taken place. Let's take example of this. When any fuel burns, just for example, let's take example of LPG gas which we are using in our cooking process. When LPG burns, we are getting heat and light. When I get heat, see, what we do is that, see, it's very common and very simple. When you put on that button or you switch on that button or whatever, when we arrange it in such a way that gas starting coming out, but that time there is no reaction. When I put the lighter, okay, or I put in matchstick, it burns. How then? How do I get to know that the fuel is burning? Because I am getting heat and light. This heat and light is indication, giving me indication that yes, chemical reaction has taken place. See, I can even burn this t-shirt. There is oxygen also in the air, but I know no chemical reaction is going to take place. Why? Because I know this is not giving me any heat and light. Okay, so whenever chemical reaction is there, it gives us some indications. It gives us some hint. Yes, if I get that hint, then I get to know yes, chemical reaction has taken place. So what are those hints? It is very important. Any chemical reaction taking place gives us hint or indications. Signs या फिर indications of chemical reaction. If chemical reaction is happening, what hint or signs I get is that I will get evolution of gas. Second one is formation of precipitate, formation of precipitate. Third is change in color. Fourth is heat. Rise or decrease in temperature. I can say just a single word, change in temperature. And fifth one is change in state. Change in state. See my dear students, this fifth property is not a perfect or proper hint because change in state also takes place when ice melts. Okay, that is a physical change, not a chemical change. Whenever any chemical reaction take place, I get these hint. These things will, either of these will take place. Moreover, more than one change can also take place. Means evolution of gas along with change in color and change in temperature may take place. Means either I will get one or more than one hint. But for sure, I have to get any of these changes or hints to confirm that yes, that any chemical reaction has taken place. We will see example one by one. First one is evolution of gas. Let us see one very common example. There is sulfuric acid in this. That is, I'll just as of now I'll just write sulfuric acid. Sulfuric acid. When we put zinc granules in this, after some time, I get to see that there are bubbles coming up. And when I take a candle, and when these bubbles come in contact with this candle, they produce pop sound. Very important. I will let you know what is this pop sound about. See, my dear students, what has happened or what has been taking place is that this zinc reacts with sulfuric acid. After that, a chemical reaction has taken place, and what product I got is zinc sulfate plus hydrogen gas. Here, hydrogen gas is a product. So when I get to see these bubbles, then I get the hint, yes, that chemical reaction has taken place. So evolution of gas is a hint or sign of chemical reaction taking place. Second one is formation of precipitate. First of all, you need to understand what is a precipitate. See, my dear students, whenever any chemical reactions take place, second one is formation of precipitate. See, whenever any chemical reaction take place, many times what happens is that if there is any solution, and as of now there is no such material in this that which is not mixing into it, which is not dissolving into it. If I add something, let's take another liquid. This liquid and liquid mix with each other. After mixing, a chemical reaction takes place. This is a substance 1, this is substance 2, these are two reactants. When they come in contact, they do a chemical reaction, and after some time I found that there is a new material I have found. New material I have found, it means chemical reaction has taken place, but this new material is not dissolving. Therefore, it is insoluble in this liquid. This new substance is insoluble in liquid. Moreover, many times this insoluble material will get in solid form, and slowly this goes and settles down. This material is known as precipitate. This material is known as precipitate. So what is a precipitate? Precipitate is a insoluble material which you get after chemical reaction has taken place. This does not dissolve. This may be get in solid form, and then this settles down. So we will just take an example in which a precipitate is formed. If there is lime water, if I pass carbon dioxide gas into this lime water, after some time I get to see something white milky in color has settled here. What has thing has happened is lime water plus carbon dioxide, when they react, gives us calcium carbonate plus water. See, my dear students, when I see this solid thing not dissolving in water and slowly settling down, I get to know that this is a precipitate. And when this precipitate is formed, this calcium carbonate is a precipitate, I get to know yes, this chemical reaction has taken place. So formation of precipitate is also a hint or indication of any chemical reaction has taken place. Third one is change in color. We are very much familiar to this process. We have done many reactions regarding this in 7th and 8th standard. Change in color. If there is a test tube and copper sulfate is in it, copper sulfate. We all know copper sulfate is blue in color. After some time, I have put some iron nails into it. Okay? After some time, I get to see that this solution has changed color from blue to red. From blue to red. This changes color is giving me a hint that yes, chemical reaction has taken place. How? Copper sulfate, copper sulfate plus iron gives me iron sulfate plus copper. See my dear students, copper sulfate had blue color, but after reaction we can see that the solution is of green color now. The reason is that a new product has formed, that is iron sulfate, and it is green in color. Okay. Okay, my dear student. One more thing that you observe is that change in temperature. Change in temperature. We can also observe many temperature changes. How? Change in temperature means either this temperature will rise or this temperature will fall down. Right, dear student? You just need to know that if I am telling change in temperature, in further time we will also study change in energy. Means either energy is required or energy is released. Rise and fall means if there are any reactants, reactant 1 plus reactant 2, any chemical process has taken place and we have got product 1 plus product 2. These are the reactants and these are the product. If after reaction heat is released, then overall heat will rise. Okay. And in any temperature, if I am getting heat in products, it is known as exothermic reaction. Means it is being released. Best example is carbon plus oxygen gives us carbon dioxide plus heat. When we burn coal, it gives us carbon dioxide plus heat. This is an exothermic reaction. And if reactant 1 plus reactant 2 are there, and I want product 1 plus product 2, but for that I need to give heat. Means this process requires heat. Okay, so what will happen is that overall temperature in the products I will get that the temperature has fallen down, and such a process is known as endothermic reaction. Such a process is known as endothermic reaction. Example is nitrogen plus oxygen gives nitrogen monoxide. For this it requires a lot of heat, and when this takes a lot of heat from the environment, the neighboring environment gets cooled down. And the best example is see my dear students, for any chemical reaction to take place, if I am taking heat, I require heat, it means I am taking heat from my neighboring. If I am taking heat from my neighboring, it means neighbor's temperature will fall. And after reaching, if I release heat, then the neighbor environment's temperature will rise. So if this thing happen, we will get to know yes, chemical reaction has taken place. One more thing is that is change in state. That is change in state. This is not that much prominent hint. This hint is not enough. This unit is not enough to let me know that any chemical reaction has taken place. Just but for example, we will take an example. If any candle burns, we know that wax is in solid form. When it burns, heat is released and this wax gets converted into liquid. Moreover, when it burns, carbon dioxide gas is released. That is a gas. It is a gas. So very important. How this solid is getting converted into gaseous and liquid form. This is also a change in state and letting me know yes that here any chemical reaction is taking place. In any chemical reaction taking place, more than one indications I can also get. Okay, see my dear students. Now we need to know what is chemical equation. What is a chemical equation? Whenever I represent any chemical reaction, what is chemical equation? Chemical equation is representing chemical reaction with formulas and symbols. If I represent any chemical reaction with formulas and symbol, then it is called chemical equation. A chemical equation is very helpful. Why? Because by this I get to know the formula of reactants and products. I also get to know which elements or how many number of atoms are taking place in this chemical reaction. For example, we saw that zinc. Not we took the example of iron. Iron plus copper sulfate give us iron sulfate plus copper. See my dear friends, in this we saw that the copper was blue in color, okay, and its color changed into green after reaction. This is a chemical reaction and I have presented it in words. So this is also known as word equation. But when I represent all these reactants and products with formulas, that is Fe for iron plus copper sulfate, that is CuSO4. After reaction give me iron sulfate, that is FeSO4 plus as a byproduct or as I will get a reddish brown color on the iron nails, that is copper Cu. Fe plus CuSO4 gives me FeSO4 plus Cu. This is a chemical equation, very important chemical equation. See, I have represented all these reactants with formulas and products with their formulas. It is very helpful to me. Why? Because I will get to know yes, which element, which atom, how many number of atoms are taking place and what material I am getting. I am getting to know yes, there is a breakdown of bonds. I can see copper and sulfate bond is broken down. This copper is broken down its bond with sulfate and iron has made new bonds. Now copper here it is having bond with sulfate, but here it is having bond with no one. So very important. A chemical reaction is a second way, or chemical reaction or chemical equation is easier way. A easier way to represent a chemical reaction. Chemical equation is easier and a simple way to represent any chemical reaction. See my dear students, there are two types of chemical equations, balanced and unbalanced chemical equation. We first of all we will take two examples and then we will see what is a balanced and what is unbalanced chemical reactions or equations. Balanced and unbalanced chemical equations. Oh, see dear students, when zinc react with sulfuric acid, we get zinc sulfate plus hydrogen gas. We saw in the evolution of gas topic. Here you can see these are the reactants and these are the products. Okay, see zinc. How many number of atoms of reactant, मतलब atom of zinc are present in reactant? One. In products, one. Hydrogen. Two number of hydrogen atoms in reactants and two number of hydrogen atom in products. Sulfur, one. Here also one. Oxygen, four. Here also four. You can see that number of atoms of any element in reactant is equal to number of element in products. Yes or no? You can see that the number of atoms of any element in reactant is equal to the number of atoms present in the product. Such an equation is called as balanced chemical equation. Such an equation is known as balanced chemical equation. In balanced chemical equation, you can see that the mass of these all atoms and mass of all these all atoms is same. That is, in a chemical balanced chemical equation, mass of reactants is equal to mass of products. Okay, just opposite to it is unbalanced equation. If number of atoms of any particular element in reactant side is not equal to number of atoms of particular element in products, then it is an unbalanced equation. Or we can say that mass of reactant will not be equal to the mass of product. It will be an unbalanced equation. Balanced means both the side equal. Unbalanced means both the sides unequal. Okay. Just let's take an example. Hydrogen plus oxygen gives us water. Here you can see hydrogen is having two atoms in reactants and hydrogen is having two atoms in products. Here you can see oxygen is having two atoms in reactants and one atom in water. Very important. Here hydrogen atoms are equal, but oxygen atoms are not equal. But it doesn't mean that this chemical equation is wrong. This chemical equation is right, but this chemical equation is not following mass, या फिर not following the law of conservation of mass. Means the mass of reactants is not equal to mass of products. It means has it mass got vanished somewhere? No. It has not vanished. Or if it is two atoms here, has one atom of oxygen vanished? No. It is still there. But this chemical equation is unbalanced. Means it is not giving me the full information of mass. So now I need to balance it. If there is any unbalanced chemical reaction, we need to balance it. How can we balance it? Very important. While balancing, I cannot change the formulas. If you are balancing, you cannot change the formulas. You can just put positive integers here in the front of formulas. I cannot alter or change the formula. So very important, to any unbalanced equation I need to balance it. First of all, how can I balance an equation? I have to do a process that is hit and trial method. This is a balancing equation is called hit and trial method. That is, I will just try by changing the number of compounds or number of molecules. I can't change the molecular formula. H2 plus O2 gives me H2. See now. We just need to compare how we have to balance any chemical equation. Just write the equation. This is right, but as I can see, yes, this is an unbalanced equation. I have to now make it balanced chemical equation. I will just compare hydrogen. Yes, two hydrogen, two hydrogen. No need to change. Two oxygen, one oxygen. Let me make two. Wrong method. Why? If I write two here, it will change the formula of water. I cannot enter the formula of water. Yes, I will put two here. Means I will just change the number of molecules of water, not the molecular formula of water. Okay. Now I have what is H2 plus O2 giving me 2H2. Now I will see. Yes, two oxygen, two oxygen. But then I saw four hydrogen and two hydrogen, no issue. Now I will make two here. I haven't changed the molecular formula of hydrogen. It is H2, it is a diatomic atom. Okay. I have just changed the molecule. It is 2H2 now plus O2 gives 2H2 and this is now a balanced chemical equation 2H2 plus O2 giving us 2H2O and this is a balanced chemical equation. This is a hit and trial method. You must surely practice this. Okay. See my dear students, if I have balanced chemical equation, moreover, I also need to make any chemical equation. How can I make any chemical equation more informative? How can I make any chemical equation more informative? See my dear students, whenever any chemical reaction is taking place, if what to do if I want to make chemical equation more informative? Very simple. First of all, you need to mention the physical state. Physical states. That is, for example, carbon plus oxygen giving us carbon dioxide. Yes, this is chemical reaction. I need to mention the physical states that whether my material I am using or I am getting is solid, it is in solid form. If it is in solid form, I will write small s here to indicate it is in solid form. If it is in liquid form, you need to use letter L, okay? And if it is in gaseous form, you need to write G. Very important, dear students. Many times the product we are getting or the reactant we are using is in water. So we will use aqueous solution. Means the aqueous means the material I have got or the material I am using is in water. See my dear students. C, coal, that is solid. S, oxygen I will be using in gaseous form. G, and CO2 is G. I have made this thing more informative. Very important. Second thing you need to mention is heat या फिर energy exchanges. Means in any chemical reaction, do I need energy or heat, or am I releasing energy or heat? For example, this is very important, you need to mention it. Nitrogen plus oxygen giving nitrogen monoxide. This information is okay, but very important, I need to mention nitrogen gaseous form, oxygen gaseous form plus heat. Now this is more informative. You will get to know, yes, until and unless we are not giving it heat, we will not get this product. Moreover, my dear students, many times heat is represented by this symbol. This means delta. If it is written on arrow or if it is on arrow, it means that reaction requires heat. Water gives H2 plus O2. This equation is right, but I need to mention plus electricity, or I need to mention electricity. Means I need to give electricity to this thing. Okay. One more example is there. LPG gas we are using is having methane CH4 plus O2 gives us carbon dioxide plus water in vapor form, that is H2O, plus heat. Very important. Whenever see CH4, LPG in gas, oxygen in gas, carbon dioxide in gas, H2O, basically it is liquid, but we get it in vapor form. You can write as G also and L also, but I am writing G. Why? As soon as that gas starts burning, that vapor is converted directly, water is converted into vapor. Plus heat. This is the best and most simple way. If you want to make more informative, you need to mention heat energy exchanges. Okay. Third thing I need to mention is conditions. Conditions. See, my dear students, many chemical equations or reactions will not take place until and unless they are given few certain conditions or they are given any catalyst. First of all, we need to see what is a catalyst. See, my dear students, catalyst is such a material. What is catalyst? Catalyst is such a substance. This substance does not take part in chemical reaction. Does not take part in chemical reaction. It is not taking part in chemical reaction. Neither it is in reactant side, neither it is in product side. But this substance is very much important either to initiate the chemical reaction or to increase the rate of chemical reaction. So what is a catalyst? Catalyst is a substance which does not take part in chemical reaction, but it is very important to initiate the chemical reaction or to increase the rate of the chemical reaction. See, my dear students, few things are such that you surely need to mention is that, for example, whenever carbon monoxide burns with hydrogen gas, we get methanol. Okay. Now see, carbon monoxide plus hydrogen gives us methanol. This is a reaction. I have made it more informative. Carbon monoxide in gas form, hydrogen in gas form, methanol in liquid form. But this is not enough. There are many conditions. Conditions I need to mention on the arrow. That is, now this is the real fact. See, this is a chemical reaction. Yes, you got to know. Now I want you to give the complete information. I need to mention 300 atmospheric pressure is required. 3000 degrees Celsius temperature is required. Zinc oxide plus chromium oxide are required as a catalyst. Until and unless these conditions are not fulfilled, this reaction will not take place. So now this is the complete reaction. I have told or let you know each and everything, the physical state, the conditions. For example, C6H12, not C6H12O6, CO2 plus H2O giving us C6H12O6 plus O2. This is photosynthesis. You will say yes, we know. See now how I am making this more informative. CO2 gaseous form, H2O in liquid form, C6H12O6 in aqueous form, oxygen in gaseous form. But this is not enough. Photosynthesis process will not take place until and unless chlorophyll is not present. So chlorophyll is the required condition. I need to write it on arrow to make the equation more informative. Moreover, it requires energy. Plus sunlight. I can write plus sunlight here, or if I am writing a sunlight here means it requires energy. This is the complete informative representation of any chemical reaction. If you want to represent any chemical reaction fully informative, you need to write mention the physical state, the heat or energy exchanges, and the must conditions required. Okay, my dear students. Basically, there are many types of chemical reactions. One by one, we will see all the types of chemical reactions. We have got to know what is a chemical reaction, what is a chemical equation, how to write any chemical equation, what is balanced and unbalanced chemical equations. Okay, now very important. Now we will see types of chemical reactions. See, my dear friends, there are many types of chemical reactions. One by one we will see all. First one is combination reaction. Second one is decomposition reaction. Third one is displacement reaction. Fourth one is double displacement reaction. Fifth one is oxidation. Sixth one is reduction. And a combination of oxidation and reduction is known as redox reaction. One by one we will see all. First of all, we will see what is a combination reaction. As by name itself you get to know, combination reaction is a reaction in which any two or more reactants combine to make a single product. What is a combination reaction? As by name itself, we can see combine. What is a combination reaction? In this reaction, two or more reactants combine to give a single product. Very important. Reactant 1 plus reactant 2, minimum 2 reactants plus more than 2. All these reactants will combine and give me a single product. Two or more than 2 reactants. On reactant side, if there are 2 or more combining, reacting, and if I get a single product or only one product, then this is known as combination reaction. My dear student, very important. In combination reaction, there is a fixed thing you get to know. Either element plus element will combine, either element plus compound will combine, or compound plus compound will combine, but for sure the product I am getting will be compound. Let's take few examples. Carbon monoxide, when burns in oxygen or combines with oxygen, gives us carbon monoxide. You can see two products giving a single product. Okay, very simple. Calcium oxide plus water gives calcium hydroxide. Two reactants giving a single product. Okay, my dear students. Compound plus element giving a compound. Compound plus compound giving a compound. Carbon plus oxygen giving carbon dioxide. Two reactants but a single product. Very important in chemical reaction, that is if any in any combination reaction, for sure the result or product I will get will be a compound. So very important, what is combination reaction? Combination reaction is a reaction in which two or more reactants combine to give a single product. See now, my dear friends, what is a Decomposition reaction. When any material breaks, what is decomposition reaction? Decompose, compose to mix, decompose to break. If any reactant goes through chemical reaction and if I am getting products more than one, two or more, such a reaction is called as decomposition reaction. Very important. See my dear friends, one single reactant going through any chemical process and giving me two or more reactions, more products after reaction, such a reaction is known as decomposition reaction. See my dear student, in combination reaction we said that we get to know that two or more were giving a single product. Very important. Decomposition reaction is just opposite of combination. In combination reaction we were getting a single product from many reactants. In decomposition, from a single reactant we are getting many products. In combination, things were combining to get one. And in decomposition, one thing is getting broken down into many. Okay, see my dear students. In decomposition, if there is any reactant, for sure it will be compound. For sure it will be compound, and compound will be giving either element plus element or element plus compound or compound plus compound. Perfect opposite of combination. Very important my dear students. If there is any compound, it means it is having more than two elements, two or more than two elements. For example, carbon dioxide. If carbon dioxide is there and I want to break this, I for sure need to break the bond between carbon and oxygen. To break this bond, I require energy. Very important. Decomposition reaction always requires energy. Always requires energy. This energy can be in any form, either light, either heat, or electricity. If I use electricity for decomposition, it is known as electrolysis. If I use heat, then it is known as thermal decomposition. And if I use light, then it is photo decomposition. We will take few examples. See my dear friends, if water is there and you put two positive and negative electrodes in it and current is passed through it, this water will decompose into hydrogen plus oxygen. For that I need to give electricity. If there is water and I put a positively charged and negatively charged electrodes, I will get gases at these electrodes. These will be hydrogen and oxygen, but for that I need to decompose them. Very important my dear students. When this decomposition is being done, just you need to memorize is that for decomposition for sure we need to give energy. But very important my dear students, decompose means to break or to separate. If I am having any metal, and we know metal is, we are getting the earth's crust, it is never in pure form, it is always either in oxide form or sulfide form. If I want to get pure metal, I need to separate this oxygen. So very important, decomposition is used to get pure metals. Very important in our digestion process also decomposition is taking place. Means a single compound is broken into many more products. Okay, my dear friends, the third category or third type of reaction is displacement reaction. We've already done this reaction many times. What is a displacement reaction? We will see. displacement reaction. In a displacement, always an element reacts with a compound, and what we get is again a compound and an element. See my dear student, what happens is that this element, as this is compound, for sure it is having more than 2 elements. What will happen is that this element will take place of these, either of these elements, and will remove that element from the compound, and a new compound will be formed, and that element removed will be separated out. This is a displacement reaction. Best example is zinc plus copper sulfate gives us zinc sulfate plus copper. This is an element, this is a metal. Copper sulfate is a compound, here copper is also a metal. This zinc taken this copper's place, and we got zinc sulfate, and thrown this out from the solution, and we got this. See my dear students, as we all know, in this reaction there is movement of ion. Copper ion has moved out and zinc ion has taken place. Copper is positive ion, here zinc is taking place of this ion. It means there must be movement of ions, yes or no? Movement of ions. We'll just take this example. If a copper sulfate is having liquid aqueous form, CuSO4, and if I put zinc granules, after some time this blue color, copper sulfate is a blue color, will convert colorless. Why? Because zinc sulfate is formed and copper is separated out. Very important, all the displacement reactions take place in aqueous form, means this compound must be in aqueous form. There is one special case. Displacement reaction always takes place in aqueous form. What happens is in this is that any reactive metal, any more reactive metal displaces a less reactive metal from the solution, and we get a sulfate or a solution of that more reactive metal, and this less reactive metal is separated. If someone says you copper granules are put into zinc sulfate, will any reaction take place? The answer is no. Why? Copper cannot take place or displace this zinc because copper is less reactive. Very important. See my dear students, whenever any displacement reaction is taking place, what happens is that in a simple language, if I say there is any metal 1 and I am taking a compound of metal to salt, any metal salt, okay? Just I will give you example also. For example, iron, this is a metal, plus copper sulfate. Let's take another example. Zinc plus acid, H2SO4, not only salt, any metals compound. As zinc is more reactive, it will replace this hydrogen, and I will get zinc sulfate plus hydrogen. Very important. This took place only and only as zinc is more reactive from hydrogen. As we know, hydrogen shows a metallic character. We will show why. We will see why in further lectures. So, if there is any element or any metal 1, it will take place of any element or metal 2 in that compound only and only if metal 1 is more reactive than metal 2. Then this reaction will take place. But if this metal 2 is more reactive than metal 1, then this reaction will not take place. As there is exchange of ion or as there is movement of ion, this compound must be in aqueous form. But my dear students, there are some special cases. In few cases, metal plus metal oxide reacts into a displacement reaction. Metal 1 plus metal 2 oxide gives us metal 1 oxide plus metal 2. In this, if both the reactants are in solid form, then also this reaction takes place. This is very important condition you need to memorize. Displacement reaction always takes place in aqueous form, but there is a special case when any metal reacts with any metal oxide and I get metal oxide plus metal, for example iron plus aluminium. Iron oxide, this is solid in form, aluminium is solid in form, and what I get is aluminium oxide plus iron. Here this is in solid and solid form, then also this reaction took place. This is very important thing you need to know. In many metal and metal oxide reactions, both the reactants are in solid form, then also reaction takes place, displacement reaction takes place. This means the thing after this reaction, temperature rises so much that this iron we get is in liquid form. You must need to memorize. Now double displacement reaction. In this single in displacement reaction, it means that there is a single displacement taking place. Means a single element will take place of another element. Now we will see double displacement reactions. What happens is that any compound 1 plus any compound 2 reacts. Any element of this will take place of this, and one element of this will come into this, and we get two new compounds, that is C3 plus C4. When any two compounds react, exchange elements, if I say exchange elements means exchange ions, and we get two new compounds. Such a reaction is known as double displacement reaction. For example is potassium iodide and lead nitrate gives us lead iodide plus potassium nitrate. See my dear students, very important. Potassium iodide plus lead nitrate, these are compounds. This lead has come to the place of potassium. Okay, this is positively charged and this is also positively charged. It has taken place of this and we got potassium iodide. Now this potassium has taken place of this. Two places are getting exchanged. This has come here and this has taken place of this, and we have got potassium nitrate. In this reaction, this is double displacement reaction. Double displacement reaction always takes place in aqueous form. Why? As there is exchange of ion, means ions or particles need to move. For movement of particles, the material or solution must be in aqueous form. Very important, my dear friends. In this reaction, this iodide we are getting is in precipitate form, PPT, and I am showing this arrow to show that yes, this will settle down. Dear students, to make more informative, in PPT you can show a down arrow, means this thing will settle down, and if any gas is evolved, you can show up arrow, means gas is released. My dear students, we are very much aware of neutralization reaction. Neutralization reaction, all neutralization reactions are double displacement reactions. All neutralization reactions are double displacement reactions. How? Neutralization reactions are double displacement reaction. Or why? In neutralization reaction, acid plus base gives us salt plus water. Acid is a compound, base is a compound, salt is a compound, and water is a compound. And we are getting two compounds combining and giving two new compounds. For example, acid HCl plus base NaOH giving us NaCl salt plus H2O water. See my dear friends, HCl H plus Cl minus, NaOH Na plus OH minus. This Na being more reactive took the place of H and we got NaCl. As now this positive ion place is empty, this positive ion has came here. This H positive ion will take place of Na, and we have got H plus OH minus. Here in the place of Na we got H plus, and H plus OH minus is water. So very important. All the reactions, neutralization reactions are double displacement reaction. Here you can see how exchange of ions is taking place. Okay, my dear students. Now we need to understand oxidation and reduction reaction. When we will get to understand oxidation and reduction reaction, then we will see what is redox reaction. Oxidation and reduction are just opposite. Oxidation and reduction are just opposite processes. See, my dear students, first of all, you need to understand what is oxidation. Then you need to understand what is reduction. See, my dear students, oxidation means first thing is gain of oxygen. If I gain oxygen, then that is known as oxidation. Or if there is loss of hydrogen, then it is oxidation. For example, any element A reacts with oxygen and they both combine. This A is getting oxygen, gain of oxygen, then this is oxidation. For example, if there is any compound hydrogen E, He, H is the hydrogen and E is any element with hydrogen. After reaction, if E and H separates, E and hydrogen separates, now this E has lost hydrogen, then this is oxidation. What is reduction? Reduction is just opposite of oxidation, that is gain of hydrogen, second is loss of oxygen. See, my dear student, if there is any element and it reacts with hydrogen and they make a compound AH, any A reacts with hydrogen form AH, so A has gained hydrogen, so this is reduction. And if there is any element, just let's say metal oxide, and if I heat it, I get metal plus oxygen. Okay, so this metal has lost oxygen, that is loss of oxygen, this is reduction. Gain of oxygen or loss of hydrogen is known as oxidation. Gain of hydrogen or loss of oxygen is known as reduction. We will take few examples. Copper oxide, when heated with hydrogen, we get copper plus water. See, my dear students, in this reactant side you can see copper is having oxygen, but after reaction it has lost, it was having oxygen, it has now lost oxygen. So copper oxide has faced loss of oxygen. Loss of oxygen is known as reduction, very important. See, CuO reduced to CO. Therefore, CuO reduction process taken place. You can see. Now you can see hydrogen is alone, but after reaction it is having oxygen. So this is known as gain of oxygen. Very important, gain of oxygen is known as oxidation. We can write H2 is oxidized to H2O. See, my dear students, if it has lost oxygen, for sure someone will gain in a chemical reaction. It will not get vanished. So very important, If there is a loss of oxygen, for sure 110% someone will gain the oxygen. It means if there is reduction, for sure oxidation will also take place. Such reactions are known as redox reactions. What are redox reactions? Reduction and oxidation taking place simultaneously are known as redox reaction. In this, Re represent reduction and OX represent oxidation. Red means reduction. Reduction and oxidation always takes place simultaneously. Such a reaction is known as redox reaction. See dear students, copper oxide reduced to copper, then copper oxide is known as oxidizing agent. Very important. The material getting reduced is known as oxidizing agent, and hydrogen is oxidized to H2O, so H2 is reducing agent. Material getting oxidized is reducing agent, and material getting reduced is called as oxidizing agent. See my dear students, now we will see how in common way oxidation's effect is there in our common life. These all are the types of reactions. You have seen all the types of reactions. Now we will see oxidation in everyday life. Now we will see oxidation in everyday life. In everyday life. See my dear students, in everyday life many reactions are taking place, but most prominent oxidation in our life is in the form of corrosion and in the form of rancidity. First of all, we will see what is corrosion. See my dear students, metals. We all know metals have certain properties. They are shiny in color, they are strong, but if they anyhow react with oxygen, we get metal oxide. It means chemical reaction is taken place, and we know the properties of metals and metal oxide are not same. It means now we are not having those properties which we want. We know metals are shiny, but they will lose their shine in metal oxide. We know metals are strong, as magnesium is in ribbon form, in metal form. But if it reacts, it will become powder. It means it has lost all its properties. If metal reacts with oxygen, we get metal oxide, and this process is known as corrosion. If this metal is iron and it reacts with oxygen, it forms iron oxide, iron plus oxygen, that is Fe plus H2O plus O2 gives Fe2O3.2H2O, or you can write XH2O. This number of water is not fixed. So this is a metal oxide. This process is known as corrosion, but especially in the case of iron, this process is known as rusting. Okay, and this is the rust. This is formula of rust. It is reddish brown. Corrosion or rusting is a process in which metal loses all its properties. The reason is that it gets oxidized or it gets reacted with oxygen, and we get a metal oxide or whatever product. See my dear friend, because of this corrosion process, there is a great loss to humans. We make iron bridges. We need to, if these iron bridges will be direct in contact with air, for sure within 5 or 10 years they will degrade or break down. Why? Because there is become metal oxide. See my dear student, what can I do to prevent metal oxide is that if any metal is there and it does not allow it to come in contact with hydrogen and water, oxygen and water, it will never corrode. For that we do the painting of this metal. For that we do the galvanization. For that we do many other processes, greasing and oiling. These all things we will be doing again in metals and non-metals. So oxidation in life, first one is corrosion and another one is rancidity. What is rancidity? So my dear students, food contains many things in there. In many food, oxygen reacts with, okay, let's see what is rancidity. What is rancidity? See my dear students, food contains fats and oils in it. What happens is that many times this fat and oil of food reacts with oxygen and we get some product. and this product is not good for our health, or maybe this is poisonous, or now this food is not okay to eat. This process is known as rancidity. What is rancidity? Rancidity is the wastage of food, or a process in which food reacts with oxygen and we get such a product that it is not fit for eating. Rancidity is a process in which a lot of food is being wasted. See, my dear students, if I want to prevent rancidity, either I need to avoid my food from getting oxidized. How? I can do a good packing of food, or we can use airtight packing. Second thing, I keep food in such containers which are having nitrogen in them. See, my dear students, if I want my food to be okay, either I am going to do airtight packing, or I would surely want oxygen not to come in contact with food, and even if it comes, it reacts with someone else. So, how can I avoid rancidity? First one is by using antioxidants, not antioxidants. Actually, we need to use oxidants, not antioxidants. Actually, for this, we need to use antioxidants. Means, just let me tell you what is antioxidants. We need to use antioxidants. What are antioxidants? Antioxidants are reducing agents. These are reducing agents. What they do is that if these reducing agents are present with food, they will not allow this food and oxygen to come in contact. These reducing agents will consume this oxygen and themselves they will get oxidized. Okay, means they will react with this oxygen and does not allow oxygen to react with food. Best examples are BHA and BHT. BHA means beauty, hydroxy, anisole, and BHT means butynyl hydroxy toluene. See, my dear students, these things are also known as preservatives. If these are added in food, what they will do is that they will themselves get react with oxygen and not allow food to react with them. Second thing is that you can put food in fridge. If you put food in fridge, the rate of reaction between them will slow down and our food will be safe. Second thing is, does not put them in sunlight. We must avoid our food to put in sunlight or at hot places. We must put them in dry place. Why? Because a dry place, these things will not react. And if sunlight is there, this reaction will go more fast, and our food will very easily get rancid or poisoned. See, my dear students, we have ourselves observed that many times in summer, food gets spoiled very easily. We can feel very see, my dear, when rancidity takes place, this food gives me hint. Why? It gives me unpleasant smell or obnoxious smell. ठीक है? This is a hint. Yes, chemical reaction has taken place. One more sign. See, if I put them in sunlight, this rate of reaction increases, and if I put them in fridge, this rate decreases. If I put all this food, or I do the packing of food in nitrogen gas, nitrogen does not react with food and my food is safe. That's why many times you feel that these chips and foods are being packed in a fully air filled plastic bags. The reason is that nitrogen is being filled in them so as to avoid the reaction between food and oxygen. And very important, our food containers must be airtight. You might have observed that mothers always keep ghee very safe and very in airtight containers, because ghee is in fat in them, and this fat will oxidize and give us a poisonous material. So as to prevent this rancidity, our mothers uses airtight containers. Okay, so dear students, our chapter is over.